Hello, my dear boys. Hope all of you are well by the grace of Almighty. After a long vacation, we are going to start our online physics class again. Okay, and we are starting before vacation. We are starting static electricity, which is our chapter 10. Okay, and today's our topic is electric potential, potential difference, and capacitor and capacitance. One of the most important topic from this chapter. Okay, so welcome all of you to my online physics class, and let's boys discuss on this topic step by step. So, my dear boys, today's our first topic is electric potential. Okay. So, what is called electric potential? An electric potential is the amount of work done needed to move a unit of electric charge from a reference point to a specific point in an electric field without producing an acceleration. Okay, so this is our electric potential, and electric potential is denoted by capital V. Okay, so here if the work done is W and the unit charge is Q, then we can write electric potential V equal to W by Q. I am repeat it again. Electric potential V equal to W by Q. Okay, here W is our work done and Q is our unit charge. Okay, and here the unit of electric potential is joule per coulomb. Here you see that, or we know that the unit of work done is joule and the unit of charge is coulomb. So we can write the unit of electric potential is joule per coulomb, but it is formally known as volt, which is denoted by V. The unit is volt, which is denoted by V. Okay, so my dear boys, this is our electric potential. Again, if we want to determine the potential difference for a sphere, then we get, let's assume positive Q charge is given to a metallic sphere of radius r, then the potential of its surface will be V equal to K into Q by R. Here Q is the positive charge and R is the radius of the sphere. Okay, and here this potential is for the sphere surface of the sphere, because the positive charges are situated in the surface of the sphere. Okay, and here we get V equal to K into Q by R. Here K is our constant. You know that the value of this K is 9 into 10 to the power 9 Newton meter square per coulomb square. This is very important value and important for MCQ question. This unit of this constant is very important for MCQ type question. Okay. So, my dear boys, you must remember that the charges are only situated on the surface of the sphere. Okay. So, if we consider a point, into the surface, into the sphere, then the here this point, the electric potential will be same as the potential of the surface of that sphere. Okay. Any point of the sphere, any point into the sphere, the potential will be equal to the potential of its surface. Okay. This is another very important information for solving CQ question. Okay. My dear boys, our next topic is potential difference. So, first question is, what is called potential difference? Okay. So, potential difference is the difference in the amount of energy that charge carries between 2 points in a circuit. Okay. So, usually we know that the charge flows from high potential area to low potential area. Okay. For some potential difference for potential difference between 2 points, charges flow from one point to another point. Usually charges are flowing high potential area to low potential area. So, for this potential difference, we usually get the flow of charge as well as current electricity. Okay. Usually, you must have seen different warning signs on electric lines like danger, 10,000 volt. Okay. You all know that there is a thing known as electric shock. It is very dangerous. There are also examples that careless people died from being If you have understood potential, then you can guess that what actually happens. If somewhere potential is high and if you touch it, since your body's potential is low, so charge will flow into your body from the high potential region. Okay. Your body will have different consequences depending on the amount of charge passing through your body. So, when the charges are passing through our bodies, then we can feel shock. Okay. And electric shock is very harmful for human body. Sometimes it's block our heartbeat. Okay. Usually it's block our heartbeat. So, my dear boys, be careful. Don't play anything directly or using current. Okay. So, now we will discuss on our next topics, because that is all for potential difference. So my dear boys, our next topic is capacitor and capacitance. Okay, here our first question is, what is capacitor? And the answer is, a capacitor is a device that stores electric energy. I'm underlining these words, that store, the device that stores electric energy in an electric field. This type of device is called capacitor. Okay, and what is capacitance? Here the answer is, the capacitance of a capacitor is the ability okay, of a capacitor to store an electric charge per unit of voltage across its plates of a capacitor. Okay, so what is mean by capacitance? The capacitance of a capacitor is the ability of a capacitor to store an electric charge per unit of voltage across its plates of a capacitor. Okay, here the capacitance of a capacitor is denoted by capital C. Okay, and according to this definition, we can write C equal to Q by V. C equal to Q by V. Okay. Here the unit of capacitance of a capacitor is farad, which is denoted by capital F. Okay. So our formula for capacitor is C equal to Q by V, and the unit of capacitance is farad, which is denoted by capital F. Now we will try to discuss capacitance of a metallic sphere of radius r. According to our discussion, we know that capacitance of a capacitor is C equal to Q by V. Here we know that for a sphere of radius r, the voltage V equal to K into Q by R. Putting the value of this potential difference or voltage, we get here Q and Q is cancelled and R will goes through to the upper. Okay, so we can write C equal to R by K. Here R is the radius of the sphere and K is our constant. The value of this constant, K equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay. My dear boys, from our previous discussion, we know that the main activities of capacitor is to store energy. Now our question is, how amount of energy it will store. Okay, so if capacitance of a capacitor is C and voltage is V, then stored energy is E equal to half of C into V square. Okay, so this amount of energy will be stored in a capacitor. Okay, so here E is our stored energy and the unit of this energy is joule, which is denoted by J. Okay, so I am repeating again, the E is our stored energy in our capacitor and E equal to half of C into V square. Here C is capacitor of a capacitor, capacitance of a capacitor, and V is our voltage. Okay. So, my dear boys, this is all for today. In our next class, we will try to discuss on uses of static electricity and many more topic. Okay. So, my dear boys, until then, thank you.